What do robots in Egypt have in common? In this video, you will find out. Step into the world of robotics and archaeology as we embark on a groundbreaking mission to explore the Great Pyramid of Giza. In this adventure, we introduce you to a team of state-of-the-art robots designed to traverse the intricate passageways and chambers of one of the seven wonders of the ancient world. Over 4,500 years have passed during the time that the Great Pyramid of Giza, Egypt's most well-known monument, has been standing tall. The tomb and the fortification are made up of 2 million blocks, but they have not been completely secure against intrusion. Ancient looters stripped the building of its priceless artifacts thousands of years ago. Since then, experts have investigated the building's inside, either by examining the structure's corridors or by using more modern measurement methods, such as thermal scanners. The structure is still guarding a great number of mysteries, but beginning in 2015, an international group of researchers, known as the Skin Pyramids team, has been employing subatomic particles to investigate the monument's undiscovered facets. In 2017, they unearthed a massive hole that they have imaginatively called the Great Void, and which is located just above the pyramid's gallery. Nonetheless, the function of this gap is still a mystery. Scientists want to solve the mystery of how two strange gaps were formed inside the Great Pyramid by using cosmic particles known as moons and potentially by employing very small robots. The possibilities vary from a new burial chamber to a construction corridor that has been closed up completely. Muons, which are subatomic particles and are regarded to be one of the most fundamental building elements of the cosmos, travel through the atmosphere of Earth and sometimes collide with anything that is solid on the ground as they travel through space. The density and thickness of a particular item impact how the muon is absorbed by the object, and this is something that can be measured. The Great Pyramid of Giza is 455 feet tall and was the highest human-made building in the world until the completion of the Lincoln Cathedral in England in the 14th century. The Great Pyramid of Giza was built by the pharaoh Khufu, whose reign began about the year 2551 BC. In an article that was released in November of 2017, the journal Nature published a claim that scientists working on the Scan Pyramids project had discovered two gaps in the Great Pyramid that had not been discovered before. The bigger of the two gaps is at least 98 feet in length and may be found directly above a massive corridor that is referred to as the Grand Gallery. This corridor is the one that leads to Khufu's burial chamber. The smaller hole may be found behind the north face of the pyramid, and it is made up of a tunnel with an unknown length. Muon detectors and thermal imaging equipment were used in order to do this research. The researchers want to carry out more muon tests within the Great Pyramid, and they are now working on constructing robots that may be able to penetrate the pyramid's smaller gap and see inside using a camera with a high resolution. At this time, the only significant piece of information concerning the greater emptiness that the scientists have is its length. There is a big difference if the larger void is horizontal or if it is inclined, said Mehdi Tayoubi, the president and co-founder of the Heritage Innovation Preservation Institute, which is one of the institutions involved with the Scan Pyramids project. There is a big difference if the larger void is horizontal or if it is inclined, said Mehdi Tayoubi. According to Tayoubi's explanation, if the greater emptiness is sloped, for example, it is possible that it is a vast tunnel similar to the Grand Gallery. If, on the other hand, the void is horizontal, then it may contain one chamber or more than one chamber. In addition, according to Tayoubi, it's conceivable that the smaller vacuum, of which scientists are already aware that it consists of a corridor, might have at one point been connected to the greater emptiness in the distant past. In order to get this knowledge, the researchers are going to install muon detectors in areas of the Great Pyramid that have not before been explored. These areas include a series of so-called relieving chambers, which may be found in close proximity to the bigger emptiness. The relieving chambers can be found directly above the king's chamber, which is a room that has a sarcophagus and is widely believed by archaeologists to have been used to bury Khufu. It's possible that these rooms were built to relieve the pressure that was being placed on the roof of the king's chamber, so as to keep the ceiling from collapsing. While the new muon tests are being conducted, another group, led by Jean-Baptiste Moret, a senior researcher at INRIA, The French National Institute for Computer Science and Applied Mathematics is constructing 2 robots that may be able to peer inside the smaller void. These robots are being developed concurrently with the new muon tests. Moritz said that the group would first drill a hole with a diameter of around 1.5 inches, and then put the little robots through the hole and into space. First, we want to send a scout robot, which is simply a pan-tilt camera with a lot of lights placed in a tube-like robot, Moritz told Live Science. This will help us get a better idea of what we're dealing with. The objective is to conduct a survey of what is on the other side of the wall and get photographs with a high resolution. Moritz said, "If there is anything that seems to have potential, then we will remove the scout robot and replace it with the exploring robot. We are now in the process of constructing a flying blimp that can be inserted inside this robot by folding it up and then inflating it from a remote location within the smaller void. The blimp would make it possible for the robot to photograph the surrounding area of the smaller vacuum as it flew around it. According to Moritz, a flying robot wouldn't have to worry about navigating stairs or rocks, and it would also be able to move more quickly and capture images from a wider variety of angles than a ground-traveling robot. They have created a functional prototype of the Scout robot as well as the blimp robot, but we are still working on building a dependable deployment and folding mechanism in order to deploy the blimp," Moritz added. "The blimp is going to be a very large structure." According to Moritz, the scientists need to obtain more accurate information on the size and position of the smaller gap before those robots can begin their exploration. He said that this is the only way the team would know where to bore a hole in the surface of the planet. According to what Moritz remarked, "Our aim is that our robots will be ready by the time the Scan Pyramids team finds out precisely where we need to drill." In addition, the Egyptian Ministry of Antiquities will be responsible for providing the robots with its final permission. The pyramid would sustain some damage as a result of the hole that has to be dug. "We are putting in a lot of effort to develop a robot that is as dependable as is humanly possible, and that causes as little damage as is humanly possible, and we are keeping our fingers crossed that we will be able to persuade the Ministry of Antiquities that this is the technology that is best suited for the subsequent step. During this interim period, we may send our robots to work in other locations according to Moritz. They include historic and industrial structures." Tayobi stressed that the use of robots for exploration is not the primary objective of the Scan Pyramids project. Rather, this is something that would be examined at a later date. Thank you for joining us on this incredible journey through the use of robots in exploring the Great Pyramid of Giza. As we have seen, this exciting news could hold the key to unlocking the secrets of a long-lost civilization and shed new light on the history of our world.